All right, my friends, we are asked in problem 3 to find all the solutions. Find all solutions, and then find particular solutions on the interval from 0 to 2 pi. All right, there are several problems in this list, and we're gonna get them all done. So 3a says, well, what if the tangent of theta equals negative square root of 3? Okay, so tangent is sine over cosine, and we need them to have opposite signs. So I'm going to draw myself a little unit circle, and I'm going to be here in quadrant 2 and here in quadrant 4, right? So think about this. Negative square root of 3 here and here, okay? So this is 2 pi over 3, right? That's our terminal angle. And this is 5 pi over 3. Notice they're on the same line. So all solutions would then be, this is just 2 pi over 3 plus 2 pi, okay, nope, plus not 2, just 1, because it only takes 1 to get there, right? Just pi k. And then for just on the interval from 0 to pi, our solutions are 2 pi over 3 and 5 pi over 3. There we go. That's part A. So then let's do question B. Question B asks, for what angles is the sine of theta equal to 0? So in my mind, I'm always thinking x and y because that's what I learned first. So y is the sine theta. So when is y 0? Here and here. So this is 0 and this is pi. So all solutions, so we just keep adding pi, we keep getting those spots. All solutions would be 0 plus pi k. And then solutions on the interval from 0 to 2 pi are just 0 and pi. Okay, fair enough. So we're going to move on. Question 3c asks, when is the secant of theta equal to negative 2? Okay, again, guys, I am kind of a big proponent of saying go back to sines and cosines. Secant is 1 over the cosine. So if the secant of the angle is negative 2, that means that the cosine of the angle is negative 1/2. Okay, so I draw my little unit circle, and I'm trying to find the place where x is negative 1/2. So it's here and here. Okay, so going back to what I know, this angle is 2 pi over 3, right? And then this angle to here is 4 pi over 3. This is why the unit circle is so important. So you just have to like know it off the top of your head. All right, so then our solutions are, all solutions are 2 pi over 3 plus 2 pi, okay, because it's only here and then all the way back around to here, and 4 pi over 3 plus 2 pi k, because here and then all the way back around. But on the interval from 0 to 2 pi, our answers are 2 pi over 3 and 4 pi over 3. All right, guys, so that's problem 13, A, B, and C. So problem 13D asks, well, what if the sine of theta plus the square root of 2 equals the opposite of sine of theta. All right, so we're getting a little tricksy here. We're going to add the sine of theta to both sides. So that's 2 sine theta plus the square root of 2 equals 0. So now we're going to subtract the square root of 2 from both sides. So that gives us 2 sine theta is the opposite of the square root of 2. So we're going to divide by 2 on both sides. So sine of theta is negative square root 2 over 2. As ever, we draw our unit circle and we say when is sine, which is y, equal to negative square root 2 over 2. So it's going to be here and here. So this is 5 pi over 4, and this is 7 pi over 4. Okay, so all solutions then would be 5 pi over 4 plus 2 pi k, and 7 pi over 4 plus 2 pi k. And then solutions on the interval then from 0 to 2 pi are only 5 pi over 4 and 7 pi over 4. So these are the solutions to 13D. So let's go back and see if we can figure out the next. 13E says 2 sine squared theta minus sine theta minus 1 equals 0. Hey, that looks like a quadratic equation. And it looks like one that I might be able to factor. So we've got 2 sine theta and sine theta. And since this is negative, we're going to have a plus 1 and a minus 1. So since this is negative, this must be multiplied by negative 1, and this is plus 1. Okay, so guys, if you need help with factoring, or if that didn't make sense to you, please come into the ILC. We are happy to go over that with you. But at this point, we assume that you can factor quadratics. All right, so if this term times this term equals 0, either this one is 0, so 2 sine theta plus 1 equals 0, or sine theta minus 1 equals 0. So we're going to evaluate them in order. So here we're going to subtract 1 from both sides. So 2 sine theta equals negative 1, and then we divide by 2. So sine theta equals negative 1/2. All right, where does that happen? So we draw our unit circle. Where is sine theta equal to negative 1/2? Well, here and here. And so those angles, looking at our unit circle, are 7 pi over 6 and 11 pi over 6. So for this part, all solutions are 7 pi over 6 plus 2 pi k, and 11 pi over 6 plus 2 pi k. And then our particular solution from 0 to 2 pi are just 7 pi over 6 and 11 pi over 6. Okay, but now let's go back and evaluate the other factor. So here we've got sine of theta minus 1 is 0, so we add 1 to both sides. And so now we're looking for the place where the sine of theta equals 1. Now, this only happens here. So this is just at pi over 2. So all solutions here would be pi over 2 plus 2 pi k, because every time you go around the circle, you'll hit it once. And then on the particular, 0 to 2, it's just pi over 2. Okay, so now we've got to put the solution to this one and the solution to this one together to get our ultimate solution to 13e. So our ultimate solution here says all solutions are pi over 2 plus 2 pi k and pi over 6 plus 2 pi k and 11 pi over 6 plus 2 pi k. And then on our particular solution from 0 to 2 pi, we have pi over 2, 7 pi over 6, and 11 pi over 6. And this is our final solution to 13. All right, guys, we're going to continue in just a sec.